Hello student. Today we are going to second lecture on chapter 4th. So today's point is the Einstein's theory of specific heat. Okay, everybody know Einstein's. So first, all the atom in a solid vibrate independently of each other. कळालं तुम्हाला जे सॉलिड मटेरियलमध्ये जे ॲटम असतील ते व्हायब्रेट होतात इंडिपेंडेंटली स्वतः okay of each other. Second, the solid containing n atom, number of atom is considered here. The solid containing n atom is considered to be equivalent to 3n harmonic oscillator. Three number of harmonic oscillator. Third, the all the atomic oscillators have the same frequency. All the atomic oscillators have the same frequencies, and this frequency is denoted by mu, u, like this, because of their assumed identical surrounding. They assume the identical surroundings. Fourth, the energy spectrum of oscillator is not continuous but discrete. समजलं? The energy spectrum जे असेल ऑसिलेटरचं ते is not continuous. They continuous नसतात but discrete. Okay. The possible energy levels of the harmonic oscillators are given by energy n is equal to n h into v. Okay. So n means ka number. Okay, and h is a Planck constant, and plus Planck constant the value is a 6.67 into 10 raised to minus 34 joules. Okay, fifth, any numbers of oscillators, right? Any numbers of oscillators may be in the same quantum state of the system. Six, all the oscillators in the assembly have Maxwell Boltzmann's distributions of energy. Okay. So in this case, vibrational modes, okay? Vibrational modes in one dimension, monoatomic lattice. Okay, point. Vibrational modes in one dimension, monoatomic lattice. So assumptions काय assumptions one, the chain contain, the chain असेल ते contain a very large number, भरपूर प्रमाणात त्याचे मोठे असते, large number n to infinity of atoms with identical masses m, identical masses कशाने denote केला m, let the atomic separations be a distance a. Okay? Let the atomic separation be a distance a. Second, the atoms move only parallel to the chain. Atom कसे move chain मध्ये कसे move होतात only parallel. Okay. Third, only nearest neighbors intersect with each other. जवळचेच काय असते intersect होतात एकमेकांना. The force are short range. त्याचा फोर्स कसा शॉर्ट असेल, कमी असेल, पण ते कसे असतात जवळच्याशी त्याच्याशी इंटरॅक्ट होत असतात. खाली दाखवलेलं बघा एन यू एन. आता इकडे प्लस आणि इकडे मायनस म्हणजे ते काय होतात इंटरॅक्ट होतात एकमेकांशी. म्हणजेच काय यू एन इज द सेंटर, देन यू एन एन प्लस वन, यू एन एन प्लस टू, यू एन एन प्लस थ्री लाईक दिस. आणि इकडं मायनस काय आहे यू एन एन मायनस वन, यू एन मायनस यू एन मायनस टू लाईक दिस, यू एन मायनस थ्री. अशा प्रकारे ते इंटरॅक्ट होतात जवळच्या याच्याशी. ओके. सो consider The simple case of monoatomic linear chain with only nearest neighbors interactions. जवळच्या ज्याच्याशी ते इंटरॅक्शन होतं. ओके. आता expand the energy near the equilibrium points for nth atoms than the Newton's second law. न्यूटन सेकंड लॉ काय म्हणतात माहिती आहे तुम्हाला. expand the energy expand the energy near the equilibrium point for the nth atom than the Newton's second law. So equations of motion becomes in this case बघा mu m mu into n double dot is the mu n m u mu into n is equal to k in a bracket mu n plus 1 minus 2 mu n plus mu n minus 1 bracket close. ओके हा फॉर्म्युला आहे कोणाचा तर हा इक्वेशन्स ऑफ मोशन्स. ओके. So this can be seen as follows. The total force of the nth atom is the sum of two forces. The forces असतात दोन forces असतात. The forces of right and left. Okay. The force of the right k is equal to in a bracket mu n plus 1 minus mu n, and the force of the left k into bracket mu n minus a mu minus n minus 1. हे दोन फोर्स असतात. ओके. मग काय टोटल फोर्स कसा काढायचा टोटल फोर्स इज इक्वल टू राईट फोर्स मायनस लेफ्ट फोर्स इथं करून दाखवलेले एम म्यू डबल डॉट एन इज इक्वल टू इन अ ब्रॅकेट मग त्याचं केल्यानंतर के इंटू ब्रॅकेट म्यू एन प्लस वन मायनस टू म्यू एन प्लस म्यू एन minus 1. The equations of motion for each atom as this form only the value of n changes. कोणची फक्त व्हॅल्यू कोणती nची व्हॅल्यू चेंज होत असते. Assume all atom oscillate. Assume all atom oscillate with the same amplitude. And this amplitude denoted by A. Okay. And the same frequency denoted by omega. Assume harmonic solutions for the displacement mu n of the form as follows. बघा mu n is equal to a expansion in a bracket I into the bracket k into x n to the o minus omega t. Velocity याची कशी दाखवली velocity is equal to mu n dA by mu n upon dt dA by mu n upon dA by t is equal to minus I omega a is amplitude तुम्हाला माहिती आहे expansion of in the bracket I into bracket kx raised to 0 down n minus omega t bracket close this equation. Velocity accelerations काय आणि this gives it gives acceleration काय mu double dot n is equal to d square mu n upon dt square is equal to I square omega square a expansional into I into kx raised to o down n minus omega t. Okay. And this is a given काय mu n is equal to काय minus omega square mu n. Okay. Undisplaced position इथे displaced position काय x raised to 0 base n is equal to na and displaced position काय x n is equal to na plus mu n. Put all of this into the equations of motion. Equations of motion मध्ये याला ठेवायचं डबल डॉट मध्ये. मग याला ठेवल्यानंतर mu n is equal to k mu n plus 1 minus 2m is the motion equations आहे. Now carry out the some simple mathematic manipulations here. Mathematical manipulations finally gives minus m omega square is equal to k in a bracket expansion e expansion I k a minus 2 plus expansion minus I k a. Okay. So after some manipulations, this simplifies to m omega square is equal to 4k sine square in a bracket k square upon 2. मग काय the solutions of the normal modes uh, Eigen values problem for the monoatomic change. Okay, हे काय आहे the equation काय म्हणते the solutions to the normal mode. Okay, eigen values eigen Higgins values problems for the monoatomic change. आता हे बघा ओमेगा एम ए एक्स म्हणजे मॅक्झिमम इज इक्वल टू रूट ऑफ 4k अपॉन एम. ते काय द मॅक्झिमम अलाउड फ्रिक्वेन्सी इज ओमेगा इज इक्वल टू मॅक्झिमम इज इक्वल टू रूट ऑफ 4k अपॉन एम. Physically significance of this result the for the monoatomic change the only allowed to vibration frequency omega must be related to the wave numbers, and wave number is denoted by k is equal to in a bracket 2 pi upon lambda bracket close for the wavelength lambda in this way the result in this way lambda is काय k wave number काय k is equal to in a bracket 2 pi upon lambda or wavelength lambda in this way. Okay, second काय the result is often called the phenodispersions relations for the change even though these are classical lattice vibration. हे कोणचं आहे मग these are the classical lattice vibrations and there are no quantum mechanics or there are no phenol phonons in the classical theory. Phonons in classical theories. So to establish which wave numbers are possible for the one dimensional change. The wave number कसे असतील are possible for the one dimensional change. We reasons as follows. Not all values are allowed because to periodicity का का अलाउड होणार नाही बिकॉज ऑफ पॅराडॉक्सिटी इन पर्टिक्युलर the nth atom is equivalent to the n plus capital N plus small n nth atoms. This means that them that means that the assumed solution for the displacement must satisfy the periodic boundary conditions. Mu n is equal to a expansional in a bracket I in a bracket again kx raised to O down n minus omega t mu n is equal to mu n plus capital N plus 1. This in turn require that require that there are a integral numbers of the wavelength in the change. So in the first BZ there are only n allowed values of k and now k is equal to k n a minus p into lambda. In terms of k, this is in a bracket n a is equal to p lambda is equal to lambda is equal to n a upon p and n a upon p is equal to 2 pi upon k and this n k is equal to 2 pi upon a into p. So where the physical significance of wave number k outside of the first Brolon Brolon zone. First, Brolin zone in a bracket minus in a bracket pi upon a bracket close less than k less than is equal to into pi upon a the question mark at the Brolon's Blona Brolani zone age is a lambda is equal to 2a into k is equal to 2 pi upon lambda is equal to k is equal to pi upon a. These k values correspond to the maximum frequency. A dilated, detailed analysis of the displacement shown that in the mode every atom is oscillating pi radians out of phase with its two nearest neighbors. That is a wave at this value of k is a standing uh, standing wave. So this is a wave black and green. Black k is equal to pi upon a or lambda is equal to 2a. This is a mu. This is a chain, and this is a green chain is k is equal to 0.85 pi upon a or lambda is equal to 2.34 a. This is a chain like this moving. So point A and point C have the same frequency. Point A and point C is the same frequency. Okay, so the same frequency and the same atomic displacement, it can be shown that the group velocity Vg is equal to d omega upon dk. There is a negative, and so that the wave at that omega and that k moves to the left. The green curve below, green curve below, corresponding to point B in the omega into k diagram, omega in the bracket k and displacement relations. Huh? So the green curve below corresponding to point B in the omega into k diagram, it has the same frequency and displacement as the point A and C, but uh, but the group velocity is equal to d omega upon dk bracket close. There is a positive, so that the wave at that omega and that k moves to the right. Okay, इथे दाखवलेलं आहे बघा. Omega is equal to into in root of k upon a group velocity ते omega upon k. Okay, and this is a zero. This side x-axis is a plus and left is a negative. Okay, so point A and C are symmetrically equivalent. Adding the multiple of 2a upon a to k does not change either omega or group velocity. Group uh, group velocity. Okay, so that A contains no physical information that is different from point B, and the points k is equal to plus or minus pi upon a have the spatial significance, and that n lambda is equal to 2 n into 2 pi divided by k, and this is equal to n 2 pi upon 2 pi upon 2 pi upon pi n upon a, and this त्याला सॉल्व केल्यानंतर 2a is equal to 2d sine 90 degree upon I is equal to d, d is equal to a. This is a sign of this graph curve. And now बघा आता the monoatomic chain, ही मोठा monoatomic chain बघा. they are the attract to neighbor. Huh? And this k is equal to pi upon a is equal to 2 pi upon lambda, and lambda is equal to 2a. And second is moving to opposite side. Some are moving to force opposite directions, and now this is a k is equal to 0 as lambda is equal to infinity. So briefly look in more details at the group velocity Vg. The dispersion relation is omega is equal to root of 4k upon m into sine k upon a upon 2. So, so the group velocity is omega in the bracket omega d omega upon dk is equal to a into k upon m brackets 1.5 and cos of 1/2 ka, and group velocity of 0 at the Borland zone erase is a k is equal to plus or minus pi upon a. This tells us that a wave with lambda corresponding to zone edges, wave number is a k is equal to plus or minus in a bracket pi upon a, will not be prograde, propagate. This that is, it must be in a standing wave. At the Borland zone edges, the displacement have the form of for the seat n un is equal to u0 uh, expansion I n k a is equal to u origin origin expansion plus or minus I in a bracket n pi upon a, and this is equal to u origin means os into bracket minus 1 raised to n. So we stop here today's lecture. After we see next lecture on tomorrow.